which is not the same as deceleration. Decreasing acceleration is not the same as deceleration, guys. You can see that the speed is still increasing. Right, that's the first thing. Then after that, which rule describes the speed and acceleration of the car is obviously increasing, right? And it's definitely not zero. So the answer should be donkey for the next one here. Yes. Hey, pass a paper to her. Because I thought she was going to sit here, but she saw her friend. Okay, anyways, understand now in this part. Anyone don't know what I'm talking about? 100% absorption rate, once again. Okay, this next question here is something relatively interesting because if you calculate, a lot of students, they do this, they see the word speed, right? And then straight away, they're going to use the formula speed equals to distance over time, right? In this scenario, guys, because the word average speed, they're asking for what is the average speed, right? And I said if there's average speed, I have to add one more letter on top here. What's it again? What do you say? Total, very good. Average speed is total distance over total time, guys. And in this scenario here, where is the total distance? 10 plus 5 plus 10 plus 5, right? Exactly 30 km. And how long was the total time? It was 30 minutes. But can I put 30 minutes here like this? Why not? Hour. Yeah, because the answer is in hours, right? So what I have to do is I have to convert this into hours first, which will be 0.5. Then I can do the calculation and press 0.5 here. And I press in the calculator, you'll get 60. Yes. Anyone has any questions? Guys, please ask. If you don't ask, I'm just going to assume that you understand. And then when I give you the next test, I realize you don't understand again. Which statement about mass or weight is correct? Guys, what's the difference between mass and weight again? Mass is measured in what? kg, very good. And weight will be measured in Newton. How do I define mass again? What did I say during the class? How do I define mass? Guys, mass is the amount of what in your body? Matter, right? And I said this dumb thing because you matter, right? Remember or not? Okay, anyways, from here, you're supposed to understand that mass is the amount of matter in your body and weight is a product of what and what? Gravity and... Yeah, that's why the formula is W equals to mg, right? Remember? Yeah. Remember? Right. So from here, we know all this information. We start off, mass is a force. Force is in Newton, mass is kg, correct or not? Impossible. Mass is measured in newtons, impossible. Weight is a force, maybe. Weight is measured in kilograms, impossible. And that's the answer is. This question now, I find it very odd that some of you guys circled resistance as an answer. How? Oh, have I even taught you guys about resistance? How come some of you guys circled resistance as an answer here? Which now I'm like, why? Right, so from here, look, listen up. The question is, two cylinders are made of the same metal. Okay, this is a very important keyword. Both cylinders have the same cross-section area, but one is longer than the other. Which quantity is the same for the cylinders? The answer here is actually going to be density. Why? Because the keyword here is the same metal. It's the same understanding, right? For example, drinking water here has a certain amount of density, and drinking water in Europe has a certain amount of density, right? Just because there are two different places, or more or less, or bigger or smaller, it does not change the density. The fact is that oil will still float on both water and metal will still sink in both water, right? So from here, I should know that as long as the same material, they will have the same density. They will definitely not have the same mass because this is bigger than this one. They will not have the resistance because you never learned that before. And they'll definitely not be the same volume, right? As you can tell, the height here and the height here is different, right? Yes.
If there's a case that I carry a smaller pool and a bigger pool, then the one is heavier. The
Smaller?
the longer pool is heavier than the shorter one.
Okay, all right.
Its density is it's also volume. It's also like not same between these two.
Uh-huh.
Yeah, how is it?
Okay, let's assume this scenario here. This is the shorter pole and this is the longer pole, right? Is this the thing you're talking about? Shorter pole, longer pole? Right. So right now, let's assume this thing is 10 kg. What do you think the mass is for this thing? Heavier. Let's say double, double the mass. Right. Let's say this volume is 10 meters cubed. What do you think the volume here will be? Yeah, it will be 20, right? So from here, density is equals to mass over volume, right? 10 divided by 10 is 1, right? 20 divided by 20 is 1, right? Isn't the density the same?
Yeah.
Ta-da! You have solved another mystery, but good. At least you asked. Okay. Anyone else with any question, guys? Okay, next. Okay, this question. How many of you guys got question number 6 correct? Can I have a raise of hands? 2.
Good.
Correct, I think. What?
Good.
2. Oh, 18? Yes, 3. Oh, you got it wrong. I was supposed to be the president of the United States as well. Okay, anyways, look at this question. Okay, guys, this one I can accept because a lot of students, even from many batches here ago, they hate to do moments. Let's try to understand what's going on first, okay? It says that the heavy beam rests on 2 supports, okay? This is one support, this is the second support. The diagram only shows 3 forces, F1, F2, and F3. F1, F2, and F3 here. And the beam is in equilibrium. First question, what's the 2 conditions for anything to be in equilibrium again?
Balance.
No.
Zero.
Very good. 0 resultant force. 0 resultant force means to say the upward force is equals to your downward force. The left force is equals to your right force, right? That's the first one. What's the second condition? 0 resultant moments. Good. Okay, so this is the first 2 conditions in your mind, right? If we understand that 0 resultant force, then logically speaking, the total upward force from F1 and F2 should be equal to the total downward force from F3, right? Make sense? Right. So right now they ask, which statement is correct? All forces are equal in size. Definitely not. The resultant force on the beam is in the opposite direction of the resultant turning force. Definitely no. So I don't even know what this says. The resultant force on the beam is 0 and the resultant turning force is 0. This means to say 0 resultant force and 0 resultant moments, right? Resultant means to say extra. For example, if I have one object being pushed 100 newtons here and being pulled 40 newtons here, resultant force is basically 60 newtons to the right. Okay, it's the same for moments as well. If let's say I have a seesaw, right? And I got a really fat kid sitting on the other side of the seesaw, and I got a really skinny kid sitting on the seesaw. Not body shaming in case anyone is wondering, right? So what's going to happen is because this guy will generate a much greater moment, a much greater turning effect this side compared to this one here. And because of that, the seesaw will definitely tilt in this direction. This is moments. Moment is a turning effect. Guys, and this is just the force which could be left equals to right, right equals to left, up equals to down. Yes, guys. Anyone has any other questions? Which chapter are you guys in school right now? What's 3? What's the name? For physics. Density, mass, weight, acceleration?
Mass.
Noise? What?
Mass.
Oh, mass. Okay. All right, so we're still slightly ahead. Ideally, I would want to be slightly ahead. We usually follow the pace of Wesley because, yeah, I like Wesley schools. But yeah. Yeah, we'll try to be slightly ahead. Our pace here will always be slightly faster than Wesley's pace. That will give me enough time to give you more exercises to do before your exams as well. Anyone here is not from the May June batch, by the way? Anyone taking you right? October, November, right? You also October, November. In your IGCSE will be in October, November, right? You also and Asian? Yeah, Wesley, everyone Wesley. Hey, did you decide which school you're going to now?
Yeah.
Which one? Which one? So are you major in October, November?
I've got both. All the options.
Oh, you mean you're taking different different subjects or different time, is it? Okay, that's good also.
January I'm taking. Yeah, but it's in February.
January? You're taking the February, March paper.
And also maybe.
Are you sure? You know what I'm talking about?
Yeah.
February, March is India only though. No, what? I'm not capping, man. February, March is for India or India paper only. Hey, don't laugh, you guys trying to implement, I'm trying to say something. No, but February, March is only for the India papers. That's why it's always harder because there's tougher. Fail. You fail, right?
Okay.
I was talking about the past year papers, I mean the exam paper from that class also I couldn't finish. Too many things to talk about. Okay, anyways, moving on to the next part here. The diagram shows 4 solid cones. The center of mass of each cone is marked by a point M. Which cone is the most stable one? And this one, I find it very weird that you guys didn't get this correct. How, if you think about which one is the most stable, right? You guys ever watch sumo wrestling before? Yeah. If you ever watch sumo wrestling, for those who never watched sumo wrestling before, usually there will be 2 really fat guys. As soon as they enter the ring, the first thing they'll do is they'll squat down. They'll like squat down and then they'll get into an attack stance. Why do you think they squat down, guys? Yes, because they're actually trying to lower the center of mass and they'll open up their legs bigger just to have more surface area, which makes them more stable. So from here, I mean, this and this is definitely not it already. No, it's not B. Oh, it's donkey. Because the center of mass is the lowest and it has the largest surface area. Right? It's the same like if you try to tilt the triangle this way, right? You'll know that this thing is not stable because the surface area is too small, right? And thus it will either turn this side or turn this side now. Make sense? Sorry? Yes, close, but not enough. Okay. Anyone has any questions? Okay, then it comes to this very interesting question, which I love the most. A lot of you guys circled C as an answer, or some of you guys even that circled A. Who was the one that circled A, by the way? Can I know your thought process on why the answer was A? So it just oh, it's A. Is it? Guys, listen up, okay? Okay, let's use this as an example. Okay, let's use this. Yeah, the answer is going to be B. Why? Okay, let's think about it this way. Okay, let's use this graph as an answer. For those that circled D as your center of mass, right? Well, what's going to happen? If let's say for some reason physics is defined today and D was really the center of mass. Oh, right. Yeah, it's actually because this will be your pivoting point against the ground, right? Pivoting point against the ground means to say this thing will start acting in a clockwise moment and the whole thing will start tumbling over, ma. Right, you guys get what I mean or not? Wait, guys. And C would be the same answer also, just that it will not generate a bigger moment because it has a smaller distance between the pivot, right? And A is like, is a special answer, bro.
My answer was you cancel mass on the guy. It's not wrong, no.
It's definitely wrong. Ah.
So you can go.
It's not on the truck, that's the problem. Okay, let's okay. What you said is okay, so his argument is that if the center of mass here acts against, let's say this as the pivoting point, it will actually balance off this thing here. So it like kind of produces a clockwise and an anti-clockwise movement. But the problem is, right, are you telling me that this truck without the man there will always fall forward? Because what you said is it's used to balance, right? Okay, I know that's an application. But are you telling me that without the man here, this truck will always fall forward? Because the center of mass. Yeah.
Then what?
Yeah, that's a putaweng, right? We call it. You know the stupid balloon thing where you punch it and then you come back up and you punch it again, you come back up. That's that thing already, right? Right. So logically speaking, B would be the answer because if this thing has a great enough mass, it will actually generate enough moment to cancel off this guy's moment. You get what I mean or not, Eugene? Who else circled a funny answer? C or not D? Yeah. Really? You deserve.
Circle C.
Yeah, I'll change the marks later for this one. Oh, okay. I'll change the mark for you later. Okay, yeah, and thus the answer is B. Okay, guys. I have another example of center of mass. Shit, I can't find the picture. Okay, let's use this as a picture. Okay, guys, you see here, so if we have something that is kind of tilting this way, right? What's going to happen is the center of mass will actually pull it backwards. Means to say, right, if we place our phone on the table, usually as soon as we let go, you'll notice that it starts tilting backwards. Right? Why? Because the center of mass will actually cause it to rotate back and balance off. You can keep tilting your phone all the way until the center of mass acts exactly on the pivoting point, which is somewhere around here. You know, like in China, there's this one guy that is damn good at balancing rocks. Have you guys seen the YouTube video of that guy before? I'll show you the YouTube video. I'll show you later, right? So this guy is basically the master of center of mass, and he'll balance anything on, right? But as soon as I tilt my phone beyond a certain angle, I know that as soon as I let go, my phone is going to fall downwards because it's already acting beyond the pivoting point, which actually causes it to generate a clockwise moment in the opposite direction already. Guys, this should be your reference, guys, for center of mass and everything else that you should understand. Okay. Yes, you won't be able to balance your phone, guys. I know a lot of you Asians like to balance the egg during a certain period of time, and then you like to post it, oh, I balanced the egg.
One, two, given the three, that also
Center of mass China guys.
Yes.
And it's usually always right there.
Google at its finest, guys. Look at this guy. He's literally right the master of balancing. Look at this guy.
I think it's just very important.
He's dedicated, bro. Look at this. How many people can do this? Okay, what's the challenge next? Yes, he has a lot of things on YouTube as well. He's like literally balancing everything. But yeah, that's the concept of balancing, guys.
Keep on.
Oh my.
Balance in all things. Okay, anyways, next question here. The graph represents the motion of a car, right? What is the distance traveled by a car while moving at constant speed? So there's two conditions here. First and foremost, you define what's the distance traveled, and then you must only find it when it's moving at constant speed. So between where and where is constant speed, guys? Yeah, between 15 and 25, this is where it's moving at a constant speed of 10 meters per second, right? So I want to find the area. How do I find an area? Sorry, how do I find the distance in a speed time graph? Yes, the area underneath the graph. By setting a calculator, you'll get 100. How about gradient? Now in a speed time graph, the gradient represents what again? Huh? Very good. It's acceleration. Gradient represents acceleration. Area under the graph represents the distance traveled, guys. What?
Oh, I got it. Y1 minus.
Oh, you want the formula also is correct. Is y2 minus y1 by the way. How do you get 300, man? I don't. Okay, and finally, the last question for ABC. The mass of an object is measured on Earth to be 5 kg. The object is taken to the moon. The mass of the object measured on the moon. The mass of the what is the object? What's the mass of the object in the moon? Next question. Well, are you telling me the mass changed? Oh shit, indeed, my friend. 5 kg. I told you this because why? Mass is the amount of matter in your body, right? Telling me that if you had 1 billion matter here on Earth and then you go to moon, you had less than 1 billion matter, guys. There's only one situation where that happens. Number one, you broke your arm off on during the rocket ship. Then yes, you'll have less matter. Or number two, there was an alien that bit off one of your legs, if not two. Then your matter will change, right?
I took it and wait.
Yes, now you know. Okay, understand, guys? Matter will not change. The amount of matter in your body will not change. I'm glad to see that everyone got P correct. I don't think anyone got P wrong, so we'll just move on. P is basically, they ask you to indicate what? Oh, good. This one did. You are. Okay, one of you guys, right? I don't know if it's you or was it you or was it you? The ABC also don't want Denmark. It's like, oh shit, was not you. It was you then.
What?
Oh, and you also, I think. In the exam paper, there was one question in the ABC you couldn't do, then you left it blank. Denmark also don't want.
No, I did all the questions for you.
If it's not, if you not for this one, it'll be chemistry. Okay, anyways. Yeah, so this question here is P, where the acceleration of the sled is not constant. There'll only be not constant acceleration when the gradient is not constant. I mean to say, if you label anywhere here, guys, if you label anywhere here P, it would have been acceptable. Yeah, now I'm talking about for this one. Do you want me to repeat? No, you don't want to repeat, or no, I don't understand what it is. Okay, anyways, moving on, they ask you to calculate acceleration, right? Acceleration at t at time equals to 1. You'll notice that, guys, let me tell you one more thing. If you're asked to find acceleration in speed time graph, right, and you see that this whole thing is a straight line, It means to say the acceleration here, the acceleration here, it's all the same, right? Because it's a constant gradient, right? Which means to say it had a constant acceleration. So from here, it's very straightforward, right? You use this point and this point now, 0, 0, and 100, 120, yeah. Yeah. And then some of you guys, even though you did the calculation correct, you gave me a wrong unit. So what's the formula for acceleration again? Sorry, say that again. Yeah, can. Which is gonna be 120 minus 0.01. What's the units by the way? Meters per second square. Who lost marks due to the units here? Okay, V is final velocity. U is initial velocity. Very good question. I asked my teacher exactly 13 years ago. Or more. Okay, the answer is because they decided to use V and U, but actually the symbols don't matter in the real exam. So meaning to say, even if you wrote A equals to final velocity minus initial velocity over time, right? They can still accept it. But the standard units are V minus U over T. Sorry, not standard units. This is a standard symbol. These are the units. These are the symbols. Yes. What? Fine. Because your speed is not correct. It's not 125. It's 120. Fine.
But the unit, right?
Yeah, but you did your working, which was correct. So I gave you 1 mark.
You can get one.
No,
Why you give it?
because he did the formula and calculation correct. He just wrote the wrong number.
I think I also did.
No.
I think so.
Okay. Any other questions?
I didn't vote the square, so do I give a mark or not?
Sorry, did you say something? Max, did you say something?
Okay, I didn't vote I forgot to vote the square my answer, so do I tick it or not?
Yeah, you have to deduct. I marked your paper already. I marked it on a different computer. I'll send you the marked paper later after class when I get home because that computer is at home. I marked all of your papers already, guys. I will send it to you guys. I just left it in the other computer. Okay, but anyways.
Teacher,
Yes.
Stephanie, you said that the point B,
Yeah.
so the speed is constant.
The speed is constant. Can you tell me why do you think the speed is constant based on graph? As long as it's a straight line, it will have constant acceleration because it has a constant gradient. No. No. Okay, then after that, guys, they ask you to calculate the distance traveled between 1 and 2 seconds, which is actually here, right? It's between 1 and 2 seconds, right? How do I find the distance in a speed time graph? No. How do I find the distance in a speed time graph again? Area under the graph, and you just do your mathematics, right? For those who are not so good with your formulas, you could do it the dumb way, which is fine. You find the area of this triangle, you find the area of this rectangle, you can find the answer already. For those who remember the formula of a trapezium, you'll realize that this is A, this is B, and this is C, right? The formula for a trapezium is times what? And you'll get your answer. And then from there, you'll find that it should be 180 meters. And I was supposed to find the area under the graph here for a speed time graph. You as well, you know. Okay, guys, any questions? $180 meters. Wow.
I
Are you guys in the same class? No?
share
Which subject? Good. Anyone has any other questions? Elizabeth, did you find it or not? Yeah, moving on. The resultant force acting on the sled remains constant during this test, suggests why the acceleration of the sled is not constant. Guys, I think we did this in class before, right? Right. Why, guys, if you talk about this question, right, they're basically relating to the F equals to ma formula, right? Listen up, by right, when I have a resultant force acting on object, it should have a constant acceleration by right. But this question here, it says that the resultant force acting on the sled remained constant. This was constant, but the acceleration was not constant. This thing was not constant. Why? Wait,
Or eat the big fire. What? So graph says that the E is higher.
Yeah, but why? They're asking you why. No, don't need. You already got it already. Why? Hey, the formula is here, guys. If I have this as a constant and this thing is not constant, there could be only one reason, right? The mass is decreasing. Very good. It's like, right, if I put numerical value, 100 equals to 10 times 10, right? But right now, the force was constant, but the acceleration is not the same. Maybe right now it's 20 already. Why? Because the mass was changing, right? So what was the reason the mass changed in this sled that is rocket powered, bro? Yeah, the fuel is burnt up lah. It's like, you know, you guys know that if later on you want to develop it into a mud pit, right? You know how to get your bike to run the fastest? You know, if let's say you want to develop into a mud pit later on in life, you don't know what's a mud pit? It's Malaysia's specialty, bro.
What is that?
They call it the Superman. What the hell? You don't know what's a mud pit? Okay lah, let me open up your eyes. This one free education. Yeah. These guys, bro. These guys, bro. Yeah, these guys are what we call the mud pits. Okay. Their specialty is to come out at 12 o'clock at night and then race all the way until 4 o'clock.
Only the
What is so comfortable
Yes,
about
yes.
this position? What is so
Sorry, what do you say?
What is it so comfortable about this position? There's nothing very comfortable about doing like this.
No, it's not for the comfort, bro. These guys are the speed junkies. They're trying to speed their bike to the fastest just for the adrenaline rush. But I tell you, usually these kind of scenarios end up bad.
How many crashes?
Huh? What?
Crashes.
Hey, how come my volume is so soft? Wait, I must have said something wrong. Wait. Oh, it's here. No wonder. Okay, sorry, what were you saying? Can you repeat that again?
How many crashes?
How many pressure?
Crashes.
Oh, crashes are damn a lot. You go search that mud bit crashes. Hey, I tell you, these are bad, man. I tell you, watch. Okay, let's watch one YouTube video. Really? Good luck to you, Mas. Hey, this is the. Watch this, watch this, watch this. Yeah, they're doing the Superman. Yes, there's no less air resistance. Yeah, you're basically small. Yeah. Hey, this they never show the video where I want to see them. Okay, so let's explain the physics in it. Okay, what they said is correct. What they're trying to do is they're trying to lower the air resistance, right? So remember that time when we were playing with the experiment with dropping the egg, we make a big parachute to increase the surface area so that the eggs will land safely, am I right? Yeah, that's why it's always like, yes, it's cutting through the air. Okay, in fact, this cutting through the air concept, right, is very, you can see it in race cars as well. Why is it that race cars is always like a sharp aerodynamic position? Because they're cutting through the air. And whereas if you compare like look at this, these are like the streamline of air that's being cut by a car. Alternatively, if you look at the lorries, right, lorries will never be faster, obviously, than cars on, because you see the air drag is so much already. The front is literally pushing the lorry backwards already. What?
The most air.
Sorry. This one. Serious. You see a lot of the lorries, they have these things, right? I'm sharing the right screen, by the way. Yeah. A lot of lorries you see have this thing where it's actually to reduce the air resistance. And now you know. By the way, you have to pay for this. See? Aerodynamic lorry. Nothing in the world is cheap, bro. Cheap thing no good, good thing no cheap. Okay, but anyways, that's that. So from here, you're supposed to understand that the mass of the rocket is decreasing as fuel is consumed. That. It seems like we won't be able to finish this paper again today. Or can we? Probably not. Next week, we'll play with the. Oh, it's equally as bad. The average, I'm actually supposed to feedback your parents on your progress. When I saw the average, right, wow, I'm thinking, what should I say to your parents?
Maybe not this.
Yeah, exactly. Exactly. That's the question that I looked at. When I looked at my phone, I looked at the average, I'm like, put it away. The average is 38%, bro. 38% average for physics, 34% average for chemistry. I'm like, so sick. Okay, no worries. It's the first time. Whatever. Okay, anyways, moving on. Most of you guys did this question correct, at least. I was quite glad. Except for this guy.
What
Say another scalar quantity, bro. You're supposed to say what is a vector, what is a scalar, bro. This guy wrote direction, right? Okay, anyways, you can literally write anything: scalar, time, speed, distance, temperature, anything that has no direction one, right? And that's damn a lot. You can write anything, right? Vector, you can write anything that has direction, moments, momentum, accelerate.
But-
Scalar, no direction. That's the depth. No. Scalar is only magnitude. Vector is magnitude and direction. Right.
Exactly.
It's like, after explaining, still exactly. Bro, 你有听我讲话了吗 bro? Are you listening to what I'm saying?
Anything with direction is
Yeah, so can I write direction? Here like this? He's like, Jaren, what's your age? My name is Jaren. Jaren, you ate lunch already or not? I'm fine. Bro. He's not answering the question, bro. So you can write anything, guys. You wrote something like time, distance, the speed, temperature, anything that's logical, right? Yeah, anything that's logical, think about it yourself. If not, you can Google it. Vector is anything with direction, moments, momentum, acceleration, displacement, velocity, blah 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 blah. Google it if you're not certain.
okay, look the second one is it's a like bonus.
Which one? This one?
The
Why?
you told us there was one question that you wrote momentum is a vector.
But still, some of you guys managed to get it wrong. Okay, anyways, moving on to the next part, guys. Hey, pay attention here. Wait. Hey, face forward. Hey, why do I feel like I always have to repeat when it comes to you? Acceleration, they give you this information, they give you mass, they give you force, which is in kilonewton. The first thing I have to do is change this into newtons, right? How much is 50 kilonewtons? 50,000 newtons, right? And calculate acceleration. Straightforward, F equals to ma already for sure. Because there's only this formula can relate these three things together, guys. When you're dealing with all these calculation questions, the first thing is always to identify what is given to you. Oh my god, have I been sharing the wrong screen? What is given to you, right? Then after that, you ask yourself, what formula relates these three things together? And since you haven't learned much, there's only one formula that relates everything together, which is this. Then acceleration will be force over mass, and you literally substitute this in only. But of course, this was the question that I want to say about Alia. Guys, if you are struggling with algebra, right, I can tell you, you're going to struggle with physics for sure. Please, hey, you also another one, I remember your algebra also not good. Please go and fix your algebra first, guys. Fix your algebra, then you can do the calculation properly. My friends, you press the calculator, you get an answer. How much? 1742 what?
24.
Oh, 2. Okay, guys, this is the next thing I want to emphasize here. What's the units? FM, not FU. Huh? FM after. Yeah, my meters per second squared, my friend. Right. Then that's not the thing I want. That's not the thing I want to emphasize. Can I write 0.1724 here? Can I? You're new. You're safe. She nodded very fast, but she's new. She's okay. Cannot. Cannot. Why not? Yes, the answer is you can only write maximum 3 significant figures here. Minimum is 2. So if you wrote 0.172 or 0.17 meters per second square, both acceptable. Anything beyond this, for sure wrong. Guys, in the real exam and in your school exam as well, if you wrote every time you write this one more than 2 or 3 significant figures, right? they'll -1 for every one calculation until you learn. But I tell you, some of you guys will not learn, just like my year 11 students. Until today, they still write me for significant figures. And I just like, sorry? No, physics cannot answer in fractions. All answers will always be decimal. But that's a good question. Answers are always in decimals, guys, in physics. You'll not, later on, when you guys go to year 11, you'll start doing past year papers, you realize that no answer is in fractions, guys. But unless they specify, write the fraction of blah, 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 then yes, but if not, no. Okay, the next question. None of you guys got it correct. All correct. The vector diagram, the dreaded vector diagram. Oh, just thinking about it, I'm having a bit headache already. Guys, this next part here, right? They say figure 2.1, which is not to scale, shows the view from the above the boat. Now on a fast-moving river, there's a fast-moving river here. The boat accelerates. Then there's a force generated here. Two forces act on the boat. The resultant force is at a right angle to the riverbank. What does this mean? What does the last statement mean? The resultant force
This is the resultant force equal
equal to? No. What does this last statement mean? The resultant force is at a right angle to the riverbank. What does it mean?
This is the resultant force that
Very good. It is 90 degrees. 90 degrees to the riverbank means to say there will be one resultant force here that is 90 degrees. But in reality, it's not really here. It's actually just from here to here only. That is 90 degrees to the riverbank. Yes. Yes, I see some confused faces. Let's see one of the questions. Okay, we understand this first, huh?
So
Which-
in other words,
Yes, I'm listening.
the
The what?
river current is pushing the boat to the left more than the force of energy.
Oh. How do you deduce that, Karen? 90 degrees, or if anything, isn't this closer than this? So if anything, isn't this force more because it's closer to this? But it's okay, we can clarify. As long as you have questions, I'll answer. Does this make sense or not, Darren? Right now, this thing is 90 degrees to the riverbank, right? And it's actually closer to this force, right? If I were to pick a wild guess, wouldn't it mean to say that this force is so big that the resultant force is closer to this force instead of this force? No. Yes. Okay, good. Okay, yes. And it makes sense also, right? I told you guys this example before. If you have two forces, acting on an object, where is the resultant force? It will always be in between the two forces, right?
Yeah.
If what? Okay, right. Next, once we understand this already, right, we start looking at this diagram. Look at this diagram. The first information they tell you is that this is the resultant force, which is actually this thing here, right? Right. And they even give you one force of the river already, which is actually this thing here, right? Right. And then the questions say it's an incomplete vector diagram of force acting on the boat. Means to say this one is still missing, right? Right. So I know for a fact that I'm supposed to connect here to here, which will give you the same direction as the one in the diagram already. Right. But that's not what the question was. It says that the force acting The force from the river current is 80 kilonewtons. This thing is 80 kilonewtons. Okay, determine the scale. What? Yes, very good. So if you use a ruler and measure this line, you will get how long is this thing? How long is that line? It'll be exactly 4 cm. If you use a ruler, you measure 4 cm. So your understanding is that 4 cm represents 80,000 newtons. But your scale, guys, your scale will always start with 1 cm. So 1 cm represents how much? 20,000 newtons. So you had a very funny answer on 1.05 equals to 19 point something newtons. Okay, this is an honest mistake. I can accept it. Guys, listen up. Whenever you have a scale, it's always 1 cm to something. It won't be like 1.5, 1.6, 1.7, or more. Yeah.
Yeah.
Oh, okay.
That's why when it's people or something, but a better is like for 1 person, like photo.
Okay lah. Oh, welcome.
I think we should accept.
No,
Yeah.
definitely wrong. You don't start with one for sure wrong, no need to complain, no need to consider already. You must start with one.
Okay.
Sit over a bit. Sit over. Squeeze a little bit, guys. It's time to make new friends with everyone. You're going to see each other forever. Sure. You want to sit here? Yes.
It's not in the middle of.
Yeah, sit here.
And you come beside it. Look at this. It's 4.2 bro. Yeah. You imagine. You, it's supposed to be just 3 points. How did you get this then? This side. I will ask you like I thought it's something. But no,
Okay. And whenever you see the word scale, you must start with 1 cm, representing blah 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 blah.
This is something like
Some form of it, yes. Some form of it, because you see for geography, they have like this. Yeah, it's correct. It's correct. It's correct. I tell you, you all don't know me. Hubert, when he learned geology, he had to measure the height of the what's it called, those mountains as well, with the map and with scales as well. Yes. She's like, didn't you ask me this question already? I'm like, okay, anyways, moving on. Next part. Then they ask you to draw. They ask you to complete the vector diagram to determine the magnitude and direction. What you needed to do was you needed to connect the arrow, the tip of the arrow here all the way to the tip of this arrow here, and you're supposed to measure how long this thing is. For those that do not measure how long this thing is, measure it right now. Tell me how long this thing is. Huh? 12.1 cm. It's okay, they'll give you a range, right? 12.1 and 12.2 is okay. Two. Okay, hey, how much? You all get 12.1, 12.2 range? Right, so with this 12.2 range, you're actually supposed to use back this thing here. If 1 cm represents 20 newtons, then 12.1 cm should be how many newtons?
It's 12.
Can. How much? 242,000 newtons. This is your magnitude. How come you left it empty? But you got the scale correct though. You didn't know you need to measure this thing, is it? Huh? Okay, very good. Okay, this is also another common question with a lot of students as well. You're going to see this word a lot, guys. Magnitude is literally just a high-tech English to say number in front of it. For example, magnitude of force, they're basically asking how much their number of force is. You get what I mean? It's just high-tech, somewhere around 12 to 12.2 cm. So 准 now, right? You did the Pythagoras theorem, is it? Yeah, okay. Okay, guys, this is something I want to highlight also. So what she did was, right, she went to use Pythagoras, right, and she measured how long this thing was, how long this thing was. That is a square plus b square equals to c square, right? This working is actually 100% accurate. 100% accurate. But you cannot show this working in the exam. Meaning to say, right, you're supposed to write it somewhere, and then you got the final answer, then you only work backwards to work all the way back to here. 100% correct one, but you cannot use this working here. So it's like for you to check your answers only. No.
I measured.
But did you measure this or not? No. Yeah.
How many words were writing?
One. Okay, then the next question is, a lot of you guys, you measured here, right? But if you read the question properly, measure the angle between the direction of the current and the force of the engine. This is the force of the engine, right? This is the direction of the current, right? You know you're actually supposed to measure here. This is between, right? This is direction of current. This is the force of the engine. Between these two is this, right? Not here, right? Yeah, it's 110.
Can I get half of the writing sense?
How do you get 90? This is a resultant force, my friend.
Can I get?
No.
Where's my 2 marks? Going.
Yeah.
You didn't have the.
What do you mean? I didn't give you anything.
I read.
Oh, okay, very good. So here is 1 mark, drawing. This scale is 1 mark, this is 1 mark, and this is 1 mark. Huh? The total is 4 only, bro. Total 9 is like everything else on top here also. Which I cut the question already, so you can ignore. If your answer is 12.175, then you take this and you multiply by this, then you get an answer here. But whatever answer you get, you can only write it in 3 significant figures. Okay, I'm going to do one last question and then I'm going to stop here already. My brain's fried already, guys.
I thought this one really.
What's happened?
So 准 acceptable? Yes, Hannah, do you want to ask anything? You sure? Yes, anyone else has any questions, guys? What? That's a good joke, guys. You still want D live, bro? How much did I say last week? Huh? Is it sure or not?
You said 75.
I never said no before. This is not a fighting class.
I said 75.
Yeah, you're gonna pass.
Either 75 and 59, not past 59. And then 1
will not be like for as what's the word called again?
Compensation.
Compensation, I think.
Compensation.
What's it called? The like
consolation price.
yes, consolation prize. Yes, consolation prize. Second place you are how much? 46. 46 is not second place. I think you are the second, right? Anyone score higher than 50? I think she was second. Then you're third, I think. No. 60 was the highest. My best of the batch. 60.
Next one, teacher.
Next one. Don't worry, it's very soon already. Yeah. It's very soon already, next one. Okay, after this week, next week we'll finish discussing the paper and then we'll do a challenge, okay? Okay, let's finish this last question and I'm done already. Hey, this one also I saw very funny looking from you. Huh? Huh? What's the formula for density, right? Density is mass over volume, right? So from here, what's this information? What's this information? This one,
Density.
The volume of the brass is 8.4 grams per cm cube.
Density.
And you're looking for?
Volume.
You're looking for volume, right?
We don't know yet.
So if you
Should be
which comes down to algebra once again, right?
so it's 8.4 B, but 8.4. 8.4 density times B is 8.4 density. Go to our density. 8.4 times 200. Let me show you.
Show me, chef. Show me, chef. 8.4 G V.
Because we move this over in times. So,
Yeah, this is correct lah.
but then what's running over here?
Oh, you are not the one. Sorry, you got it correct. Sorry, you are not the one. Someone multiplied one. I have to go around and see who's that funny someone. This one here. Good. I won't worry. Yes, me also. I think. Oh, it'll be on it. You're going to be correct. Okay, comment. So, yes, anyways, algebra. Right? From here, press in your calculator, you'll get something. What's the answer again? 23 point. What's units?
TM.
If you wrote 24 cm cube, also acceptable, guys. Yes, because it's two significant figures, my friend.
Minimum 2. Minimum 2, maximum 3.
Do I need to bring a cane to beat you guys soon? Just like the olden days. Okay, anyways, next question. So, like I said, guys, look at this part here. Whenever you see the word sink or float, your answer should revolve around what keyword? Density. Why does it not sink? Because it
Because
you write more dense than water. I think one person also wrote the wood had a higher density than water and does not float like something. Bro, if the wood is denser than the water, then the wood will sink, right? It's more dense, right? It means. Okay, yes, and finally, the last question here, which also very little of you guys got. Hey, this question we did it in class before, right? For those who were here during the density chapter, I said that this question, look how they set this question up. They set you up with saying that the wood does not sink first, right? It does not sink. Then after that, they say that this wood you need to find the volume of the wood. Usually, if it's an irregular wood, if it's an irregular piece of object, we'll throw it in the water and watch the water displace upwards, right? But right now, this wood does not sink. Meaning to say, if you throw it in if you throw it in water, the wood will just be floating here. But it's not enough. Even if you go up a little bit, you can only find the volume of the thing that is submerged only. I want the volume of the whole wood. How? How do I pin it down? Yeah, I'm actually supposed to tie the brass object. What? Yeah, I think you wrote very well for this one. You're supposed to tie the brass object on the wood, let it sink all the way, right? Then, so your situation will be something like this. Hey, shut up, don't disturb the class. Okay, you have the situation like this. Initially, this is the volume of water, right? Then you tie the wood along with the brass inside. The wood and the brass inside, you'll get the volume of brass plus water plus wood, right? But right now, I want to find the volume of what? I only want to find the volume of the wood there. Given that the volume of the brass is already this already, what should I do? Yes, I'm going to take whatever value here. I'm going to minus the volume of the brass. I'm going to minus the volume of the water. And I'll be able to find the volume of the wood, guys. Does this make sense or not? I repeat, so you have 3 volumes here right now. You have the initial volume of the cylinder with just water inside. Then you already found the volume of the brass, right? Then when you tie the wood with the brass, you'll get the volume of the brass, water, and wood. Wait, pay attention now. Okay.
But they say that one wood only.
Yeah, so you have to minus everything off, right? You minus this, you get this, right?
Can I say?
Yes, you say, Yes, Hannah, what do you want?
Can I say measure the length?
This is an irregular shaped wood, bro. There's no width, length, or height. It's like you pick up a stone and you want to measure the length. Can or not? Yes. Because if without the brass, the wood will just be floating on top. I can't find the volume of the irregular shaped wood.
So it's
Of course, it says here at the start. Right, pay attention, boy. Okay, If this was a regular shape, would this question not exist already, bro? How to ask you a question if they... Yes. Yeah, then you say you measure the width, the length, and the height. Just like in primary. Okay? You understand or not now? So you have a few things, Number one, you have the volume of the water, and you have the volume of the brass. They're going to tie the brass with the wood into the object, and you're going to let them sink and find the volume. Then whatever volume this is, you minus this, you'll get the volume of the wood already. Good. Guys, that will be it for today. We'll continue this next week. Don't lose the paper. Yeah! Okay, guys, don't lose the paper, guys. I will continue this next week, guys. Then we'll continue with the momentum chapter. Okay, goodbye, everyone.